This is a second tutorial for converting pictures from TeX to tactile graphics. So, but before I explain this procedure, I need to say something for the last part of the first video. Because someone may not want to run the script I presented there, the Nemeth to ODT, or may have trouble running it. In this case, you can do it manually from the Nemeth file, and continuing from last time, assume we have our Nemeth files, and we want to create the ODT manually. So these files are UTF-16. We typically convert them to UTF-8 using icon, and we will translate them from UTF-16 to UTF-8. The file, let me convert the file1.nemeth and write file1.txt. Now file1.txt is a UTF-8 file, and you can open LibreOffice and import it, open it, file1, what was file1.txt? File1.txt, okay, open. Okay, now you see this is not the break you expected probably. This has to do with the font. The default here is Liberation Mono, so I have to select all of it using the menu, Edit Select All, or Control A if you prefer. And a font which is okay is the Deja Vu Serif, so I will change this to Deja Vu Serif and press enter, and of course you see here that you have the correct format for the file. You save it and you take it to the embosser. So this is you save it as open document text. Let me also add here that at the embosser, in order to be able to emboss, you need to have installed the ODT to Braille plugin from the plugins of the LibreOffice. Okay, so this is okay, I don't think I have it installed here because I don't have an embosser, but you go to the, or you search the internet for the ODT to Braille. It is a plugin of LibreOffice. You install it, and this will drive your embosser, and you will be able to emboss the ODT file. Okay, so this for the last part of the conversion. Let me now turn to tactile graphics. So I close this, I don't need it. Okay, let's see here. We have this picture, for example. This is the graph of a function, and this is the source in PS-Trix. Now, of course, you may say, why PS-Trix? Many people use the TeX package. Okay, this is there is a problem with TeX. I don't think currently that we can support TeX because the syntax of TeX uses like the plain TeX uses words which are not grouped in braces or brackets, or they don't start with backslash. For example, they use just the word node somewhere after a draw command. They have node or other kind of commands which are just plain words, and the converter cannot know if these words, there is no way to know if these words are commands for drawing, or that they can that they should be translated to Braille. On the other hand, PS-Tricks, as you see the code here, everything is either in braces or parentheses or brackets, or they start with backslash. So the converter, it is easy for the converter to know what is a command and what is text to be translated to Braille. And so we will stick with PS-Tricks. If you know how to make graphs with TeX, I think it's not very difficult to learn how to do it with PS-Tricks. There is extensive documentation for PS-Tricks, and you can always make very nice graphs with PS-Tricks. Okay, so since I explained why we don't deal with TeX and we prefer PS-Tricks, let me now proceed with the conversion. The first thing is the following. This is a picture in a file. It's not in the main file. What if you had the code of PS-Tricks inside your main file? Let me open the chapter 1 my TeX file TeX. Okay, because in the first video I removed a block of code that was loading a graphic, this one, which I will now enable. Okay, you see here I have a figure, and inside the figure you could have PS-Tricks code if you wanted. Okay, so now I don't have PS-Tricks code, I just load the PDF. But in both cases, when you run LaTeX to Nemeth on this file, if I run LaTeX to Nemeth file.tex file.aux, as we did last time in the first video, what will happen is the following. The converter will convert to Braille the main text, but when it sees a figure, it copies the contents from figure to end figure in a separate file, which it's named picture 1, picture 2, picture 3. And at this point here in the break document, it leaves a comment for the reader to see picture, that number, picture 1, picture 2, picture 3, and it takes the number of the picture from the AUX file. So if you have code inside, then you will receive from running the converter, you will get a TeX file for each picture. Now the converter does not know if you indeed have code here that draws the picture, or you just load the PDF file. So even in this case, where I don't have code, it will create a picture file with the content containing include graphics. Let me run it. Okay, but you see here now it created picture1.tex, which was not it didn't exist in the first video, because this block of code of the TeX file was commented out. Now if I open this file, it's UTF-16, so I cannot really read it here, but I can convert it to UTF so that my terminal sees it from UTF-16 to UTF-8 picture, and you see it created a document and converted here a figure, caption, and it also has left comment in the file It's not only a figure, it's figure and the number found in the AUX file. Okay, so now this file is useless for us because we didn't have code. Our code is in a separate file, which is pic.tex, the TeX code. So I just wanted to say that the converter, when it sees a figure, it will leave there a comment in the break file that the user should look at picture 1, 2, or 3, whatever. So let us turn now on how to convert this graphic to a tactile graphic. Okay, so we will just run the converter on this, and the converter will not touch the commands that we have here, except that we will convert all labels like this one, okay, the SQRT of 2 plus SQRT of 5. It will convert them for us to Braille. So let me do that. So LaTeX to Nemeth, pic.tex, pic.aux. See here, it created picture 1 and it created picture pic0 Nemeth. Now, let me convert picture 1 again to UTF-8. You see here now, the picture 1.8 contains the TeX code inside. So let me open with my editor picture1.tex. Okay. If you see here, the converter has done the following. Okay, this is a small bug of the converter. We miss new lines here. But if you see closely, the commands are untouched, except that it converted the arguments that produce these numbers, or the X at the axis here, or Y at the axis is the Y found here in my picture. There is also a small bug because I see here 2 new lines that didn't work correctly, so I will remove them. You can of course press some enters if you want, just to read easier the code, but you don't have to. Okay, now the picture 1.tex file is ready to be converted to tactile graphic. Now, how we do that? The converter was used just to change the labels to Braille. Okay. Now, what the visually impaired person need to be able to read the tactile graphic? They need to have lines at least 1.2 millimeters wide. Usually we use 1.2 millimeters to 1.8 millimeters, and personally I use these two numbers, 1.2 and 1.8, for different parts of the graph. For example, here I will change the width of the graph of the function to 1.8 because this is the important part of the graph, and axis and dashed lines will change to 1.2, so it is easy for the reader to feel with his or her fingers what is the important part here and what are the axes or the dashed lines here. So how to do this? You can do the following. You can, for example, you can set everything to 1.2, PS set line width to 1.2 mm, and especially for the plot commands, these are the plot commands here. One plot command. These plot commands plot the function, okay, this block here. We will change this to 1.8 millimeters. So I will go here inside the optional argument and add line width for 1.8 millimeters and copy this to all plot commands. Okay. Okay, now the last one is the tangent here, this line. So you may decide if you want it to be 1.8 or you prefer to leave it 1.2. Let me leave it 1.2 for the moment and save the file. Now there is one more thing to change. These files are produced in special equipment. They don't go to an embosser. They are printed as PDF files in special equipment with special paper, which is called microcapsule paper. The person cannot fill the 10 points Braille for the labels because these will not be exactly embossed. It's a different procedure with a microcapsule paper. So we have to enlarge them, and usually we have to use a size of 22 points at least. So I will come here and add a couple more lines, use package default font setup, or you may just load the font spec package. But for the labels here, you need to use a font that has Braille, the correct Braille patterns. Let me do that, set main font. And I will use the Sans family from the New Computer Modern family. So new CM Sans 10 minus regular dot OTF, but this needs to be scaled to 22 points, so I will scale by 2.2. Okay, now we are ready to produce the tactile graphic. Let me so I will just run now LaTeX or LaTeX, whatever you prefer. It's picture 1. Yes, because the converter removed my PST plot package. I added it. Let me try again. Okay, this is correct. Okay, there is a warning here of LaTeX for the graphics that transparency ignored, etc. But we don't use transparency. If you don't want to see this warning, you may either run Lua LaTeX or you may run LaTeX unsafe. This one. This has to do with GoScript converting from PostScript to PDF. Okay, so either this produces no warning, or you can use Lua LaTeX, which does not use GoScript. Okay, so I have my PDF file now. Let's look at it. Let me open it with Ocular. So you see, now everything is okay, as you see. The lines are wide enough. There is only a final problem, and this has to do with the fact that the labels, the root 2 plus root 5, minus 1, y, x, they have become large enough compared to the graph, and they may not be at correct positions. Okay, this number 1 I will remove. Okay, so I may add, for example, page style empty to remove the number 1 here. But probably you have to reposition the break for the numbers here, or the labels y and x, or whatever other you have. Okay, so to reposition this, I have find the following. Of course, you can do it with PSTeX. Okay, so you can have here, these are the labels. So you can move them around by modifying the coordinates. This is one way of doing it. Okay. Another way is to use Inkscape. So let me run this again to remove the number 1 at the page bottom. Okay, so now this is gone. And let me open this file with Inkscape. Inkscape is available on both Linux, Windows and Mac, so you can have it, it's a free software. I will use Cairo import. Okay, so with pressing Control you can zoom in, or you can zoom in from here. Right, so I need to move this. Okay, so I have a -1 here. So okay, so this is a -1. This is minus number sign 1. I have to move it a little bit up. Okay, now, of course, it is not very easy, but a person, visually impaired person, I think will handle this. This number -1 here is for this point, but this one should refer to that one, so I will move it below here. And I will deal similarly with this. There is an X here at the axis. Let me move. I use Shift. I keep Shift pressed and press the arrows of the keyboard up and down to move it for a good amount of space. So I'll bring this up here. Okay. So here is my X, it touches the axis, let me move it a little bit lower, okay, and the +1, the 1, okay, so let me move this here. Okay, so this file is now ready to be used. This is the Y axis, the Y on the axis, this one, and the file is ready to be given to a person who needs it to print it in the special printer on microcapsule paper. Okay, so this is the end of the second video about tactile graphics. Let me add here that there is a chat room for LaTeX to Nemeth in Matrix. You can reach this through the app.element.io, and I will put some information at the description of the video when it gets uploaded to YouTube. So using this room you can reach me if you need any help with a converter, something goes very bad and you don't know what to do, you can always ask, or you can use my email found on my webpage at the Department of Mathematics, the University of the Aegean. Thank you for watching.